Every four-stroke motocross engine on the planet uses valve springs. KTM, Honda, Yamaha, they all rely on the same basic principle. A cam lobe pushes a valve open, and a coiled spring slams it shut. It's simple, proven, and it works. But Ducati made their engine different. Their motocross engine runs a Desmodromic valve train, no springs. The valves are opened and closed mechanically, by the camshaft itself. That's not a marketing gimmick, it's a fundamentally different architecture, and understanding why it matters starts with understanding what springs actually get wrong. The problem with springs. A valve spring works under tension. When the cam lobe lifts the valve open, the spring compresses. When the lobe rotates past peak lift, spring pressure forces the valve closed. At low to mid RPM, that works fine. The spring has enough time to fully seat the valve before the next combustion event. But push RPM high enough, and the spring starts losing the fight. The valve train has mass, the valve itself, the retainer, the spring, and at high engine speeds, that mass wants to keep moving. The spring can't close the valve fast enough to track the cam profile accurately. That's valve float. The valve bounces, doesn't fully seat, combustion pressure leaks past it, and power drops. Worse, if it's bad enough, a floating valve meets a piston. That's a grenaded top end. Engineers fight valve float with stiffer springs, titanium valves, and lighter retainers. But stiffer springs create their own problem. More friction, more heat, more load on the cam and follower. Every solution is a compromise. What Desmodromic actually does. Desmodromic, from the Greek desmos, controlled, and dromos, course, replaces spring closing with mechanical closing. Each valve is controlled by two rocker arms. One opens the valve by pushing it down off the cam lobe, and a second closing rocker hooks under a collar on the valve stem and physically pulls it shut, driven by its own cam profile. The valve doesn't rely on stored spring energy to close. It gets driven closed just like it gets driven open. That means at any RPM, the valve follows the cam's exact geometry. No float, no bounce, no spring rate compromise. The closing event is as precise at 11,900 revolutions per minute as it is at 3,000. And 11,900 revolutions per minute is exactly where Ducati set the rev limiter on the Desmo450 MX, a number no conventional spring-based MX motor touches. Now look at the valve specs themselves. The Desmo450 runs 40mm titanium intake valves and 33mm exhaust valves. And those exhaust valves have hollow stems filled with sodium. That's not exotic for the sake of it. Sodium melts at operating temperature and sloshes inside the stem, acting as a heat pipe, pulling thermal energy away from the valve head and transferring it into the valve guide, where the cooling system can manage it. It's the same technology used in high-output motorsport engines, precisely because exhaust valves run in an environment where heat buildup kills reliability. Ducati didn't bolt a road bike valve train onto a dirt bike. They engineered every component for the specific thermal load of a race motor running at the top of its rev range. Why Ducati has always done this? Ducati's been running Desmo on road bikes since the 1950s. Fabio Taglioni engineered it because at the time, metallurgy wasn't advanced enough to build springs that could handle race RPM reliably. Springs would fatigue and fail at the speeds Grand Prix racing demanded. Mechanical closing was more dependable and more precise. Modern metallurgy mostly solved the spring fatigue problem for road use. But Ducati kept Desmo because at the sharp end of performance, MotoGP World Superbike, the rev sealing and valve train precision still deliver a measurable edge. Their MotoGP Desmo450 makes over 260 horsepower, in part because the valve train can be pushed further than any spring-based system allows without penalty. Bringing that architecture to motocross isn't nostalgia, it's a deliberate performance argument, and the idea started taking shape internally at Ducati as far back as 2021. How the engine is built around the concept. The bore and stroke of the Desmo450 are 96mm by 62.1mm. That's a significantly over square configuration, wide bore, short stroke, which is exactly what you'd expect from an engine designed to breathe at high RPM. A short stroke means the piston travels less distance per revolution, reducing piston speed at a given RPM and allowing the engine to spin higher before mechanical stress becomes a limiting factor. The wide bore gives you the valve diameter real estate to flow serious air volume, which is why those 40mm intake valves are possible. On a more conventional bore size, you couldn't fit them without compromising port geometry. The throttle body is a Mikuni 44mm unit, sizable, direct, tuned for immediate response. Fuel delivery is managed through 2 riding modes and 2 throttle maps out of the box, with full customization available via the Ducati X-Link app over Wi-Fi. That's not standard MX fare. Neither is the electronics package more broadly. Traction control that reads actual rear wheel slip using camshaft rotation speed, cross-referenced with inertial measurement data, launch control with 3 stages, engine brake control, and an upshift-only quick shifter. The traction control is sophisticated enough to recognize when it's in the air off a jump and stand down. It doesn't chop power mid-flight and send you OTB on the landing. That system is patent pending, and it earned the Desmo450 the title of the first motocross bike ever to offer that level of slip detection. The cooling architecture matches the engine's ambition. Twin rhomboid-shaped radiators give 6.5% more surface area than conventional rectangular units, while keeping the frontal package compact and the weight central. You can't run a motor to 11,900 revolutions per minute in a full moto and keep it honest without a serious thermal management strategy behind it. In a motocross context, the advantages. The rev ceiling is real and it changes how the bike behaves. Ducati claims 70% of peak torque is available at just 4,200 revolutions per minute. That's corner exit traction and drive before you've even started climbing the power band. Then the engine keeps pulling, cleanly, all the way to 11,900. That's a wider usable band than most 450s can offer, and it means fewer gear changes in rhythm sections and tighter technical tracks. Less shifting means less disruption to chassis balance midsection, which is a real competitive advantage in Supercross, where rhythm lane decisions happen in fractions of a second. The cam profile flexibility matters too. Because you're not constrained by whether a spring can snap the valve shut at peak lift, Ducati's engineers can run more aggressive valve timing, wider duration, more lift, without the closing event becoming a liability. The result is better top-end breathing without sacrificing the bottom-end torque curve. That's genuinely difficult to achieve with a spring-based system without making compromises elsewhere in the map. There's also a friction advantage. Valve springs in a conventional engine are always loaded, even at idle they're under compression, pressing against the cam follower constantly. Desmo eliminates that constant spring load on the cam lobes and followers. Less parasitic friction means less heat generated in the valve train, and marginally more of the engine's energy going to the wheel rather than being absorbed internally. They proved it before it was for sale. Ducati didn't show up to MXGP with a concept bike and a press release. Before the Desmo450 MX was a production motorcycle, they went racing with it. 9-time FIM Motocross World Champion Tony Cairoli was brought in as a development rider. That's not a name you attach to a project unless you're serious about what it needs to do under race load. Alessandro Lupino ran a pre-production version in the 2024 Italian Motocross Championship and won it outright. Not top 5, won it, on a bike that wasn't even final spec yet. When the production bike made its MXGP debut in 2025 with Jeremy Seewer and Mattia Guadagnini, it grabbed both hole shots in its first 2 rounds. That's the Desmo advantage in its most literal form. A motor that pulls harder out of the gate because it can rev faster and cleaner than anything else on the line. The hole shot isn't won in the first corner. It's won in the first 2 seconds off the gate. And that's exactly where an 11,900 revolutions per minute ceiling with 70% torque at 4,200 earns its keep. The maintenance reality, not what you'd expect. Here's where the narrative around Desmo and motocross usually goes wrong. Most people assume a more complex valve train means more frequent service. With the Desmo450 MX, that's not what the data shows. Ducati set the valve clearance check interval at 45 hours. Piston replacement also at 45 hours. Full engine service at 90 hours. Oil and filter every 15 hours. Those numbers are competitive with conventional 450s across the category. Ducati specifically calibrated those intervals against their factory MXGP riders' usage, not conservative desk estimates, and they're standing behind them publicly. That said, the complexity of a Desmo service is real. When you do check valve clearances, you're shimming 2 rocker sets per valve, opening and closing, with tighter tolerances than a conventional system. Too much closing rocker clearance and the valve doesn't fully close on time. Too little and you're preloading against a seated valve which wears the collar fast. The interval is manageable. The procedure demands a mechanic who understands the system. Ducati addressed this directly. Dealers had to pass a specific assessment and training process before they were approved to sell and service the Desmo450. That's an unusual step for a motocross brand, and it tells you Ducati knows the system punishes ignorance faster than a conventional 4-stroke will. The parts ecosystem is also narrower than the established brands. Valve train components for a CRF 450R or a 450SXF are on every supplier's shelf worldwide. Desmo-specific parts run through Ducati's network, which is expanding in the moto space but isn't at KTM or Honda depth yet. For a factory-supported program, that's a non-issue. For a privateer racing regionals in a remote area, it's worth factoring into the decision. The fundamental question, advantage or liability. At the professional level, Desmo in motocross is a legitimate performance tool, and the race results already back that up. The rev ceiling, the cam profile flexibility, the friction reduction, the torque spread, those are confirmed, engineered advantages, not claims. A 9-time world champion tested it, a championship was won on it before it was production spec, and it's already hole shot MXGP rounds. At the privateer level, the service complexity and the narrower parts network are the honest friction points. The service interval won't hurt you. It's competitive with the field, but the service procedure asks more than a conventional four-stroke does, and the support depth behind it is still catching up to the established players. Ducati also has a Desmo450 Enduro in development, which signals this is a long-term platform investment. The ecosystem will grow, but it needs time. The Desmo system is not a liability but a commitment. The engine underneath it is extraordinary by any mechanical measure. Whether it's the right tool comes down to one question: what does your program look like, and who's turning the wrenches? Ducati rethought the valve train. Yamaha rethought where the engine sits entirely, and what that does to mass centralization, chassis balance, and corner entry feel is just as radical. That video is up next.